Good morning, Year 11s. Welcome to the first of two videos on the sine function. First of all, let's look at what a sine graph appears like and how it's produced. So a sine graph starts off with us looking at the unit circle. And if you imagine here, where the angle is 0, the size of sine, or the magnitude of sine, is also 0. We've seen that before. As this angle increases, what happens is this red line here will be the graph. And you can see how it is growing as the angle increases, at least initially. And as we reach pi on 2, or 90 degrees, we reach this peak. And we should know that peak is 1 high. I hope you can see my cursor on the screen, but that at 90, we're at 1. And we head round. Oh, okay, you're going to get a replay because I missed the wrong button. As we continue on, note that this is in radians, we'll get to about 3.14, which is where we hit pi. There. As we get pi around, we're going back down to 0. So in the first pi, we have completed one peak and then back down to 0. And continuing like this. At 3 pi on 2, we're at -1 and back to 0. And that is one complete rotation through sine. So, to look at that in a little more detail, or if you to write down as notes, here is what one rotation of sine looks like. Peaking at 90 or pi on 2, 0, a trough or a nadir, the low point, back to 0. And note, this continues going, because we know that we can go past 360 degrees, and we know that we can go back in negative. So, unit per circle repeats itself after one full revolution. So the period of this, and remember from the last video, period is how long it takes to repeat, is 2 pi, meaning after 2 pi it starts repeating. Has a maximum of 1, minimum 1 on the unit circle, therefore the amplitude is 1. Remember here, amplitude is the gap between the center line and the peak, which will be exactly the same as the gap between the center line and the trough, or the minimum. Alright, now this curve is cool, and what's even cooler, we can transform it and turn it into the same shape, but modeling very different sets of data and scenarios. And in order to learn how to manipulate this graph, we need to add a few more variables in. So we can put a variable at the front, which we traditionally call A, B, x takes c, plus d. Now, all of that looks very odd, but I'll show you what it looks like on GeoGebra, which is a sine graph here. So on GeoGebra, this is the initial graph, and this is the graph that you've just seen, where there's a 1 there, and then those are 0. So this is essentially looking like y equals sine x. And you can see that it crosses at pi and back up at 2 pi. Now note, if we change this a at the front, so when a is 5, that's the front number's 5, we still are crossing at the same points, pi and 2 pi, but this time our amplitude has changed. Essentially, we're multiplying sine x by a constant, which increases the maximum minimum it could possibly have. Instead of having a previous maximum of +1, it now has a maximum of +5, because when we multiply that 1 by 5, we get up to 5. The zeros, or the roots, don't change because we multiply a 0 by 5, it's still 0. So it's still crossing at the same point there. So here, and if we make it -5, what happens is we flip the graph. So instead of the +1 occurring here, we multiply it by -5, and it goes down to -5. Right, so that's the function of a. And I'm going to try and set it back to 1. Oop, I'm moving the wrong one now. 1. Alright, so back at our original graph. So you should be writing down, note to yourself, this number here in front of the sine adjusts the amplitude. In fact, don't bother writing notes because I'm going to give you that to print out in a second as a spoiler alert. But let's just see how, and I encourage you to get on GeoGebra via this link and have a play with this. Alright, let's look at what B does. B is this end one here. This final term that's hanging on the end. Note that the rotation they've used is different to the one I gave you in OneNote, but it's the position of the letters that counts, not what we actually call each letter. This B term here just moves the primary axis. So note, nothing else has changed except it's translated. And of course we can combine that with our A term. So if we make oh, a 5 again, and then move it with b, the entire thing shifts. So you can almost imagine a tide line here. Tides never really go into negative. They just go different distances from, or the water level changes in height. This might be a low height of 2 and a high of 12. That's quite an extreme tide. But we can adjust this by moving each of these around. Alright, so back to the start. Let's look at E. E in this case, here, adjusts the horizontal translation. So we just move it backwards and forward. The reason this happens is because we know that sine hits 0 at pi. If we put a minus a half in here, or minus a half pi, what that means is that sine has to reach 1.5 pi before hitting 0 for the second time. So it'll hit 0 at 1.5 pi rather than at pi. And that, I think, is intuitively difficult to understand, so we'll spend more time on it in class. B here, oh, we did B, E. Okay, this seemed like a good idea, but now it's just turning fiddly. N adjusts the period of pi. So remember how when we were looking at trig equations, how if we had cos of 3x, we knew that it would go around the circle 3 times within 0 and 2 pi? That's what adjusting B does. It shrinks the amplitude. So not B, N, this little one in here, shrinks the amplitude, or if we stretch it out, we can stretch the graph out a very long way. Alright, so how do we actually use this to model? And what notes do you need? Okay, these are the basic notes you need. Here, you need to know where the principal axis is. It's that N1. You know the period, which will be this, and we'll work more on that. That was the tricky one. And the amplitude is the size of A. Note, this here, that is the modulus of A. That's how big A is. So if I said 7, the size of modulus 7 is just 7. But if I said minus 7, the size of modulus minus 7 is also 7. It's how big the number is. Alright, some more notes for you. By all means, print them out. They'll help you through the questions. Alright, so let's say we're given a sine graph. Looks like this. What is the equation of this function? So the equation of this function here, we essentially need to fill in all the blanks with information from this here. Now, what you want to do here, the first step I think is work out the principal axis, D. Principal axis D you find by doing max at plus min divided by 2. 1 and minus 3. If we have 1 and minus 3, 1 plus minus 3 is minus 2, divided by 2 is minus 1. The halfway point of this line is going to be through minus 1. So that is the principal axis. This letter on the end here, for us anyway, is minus 1 in this case. So we're rotating around minus 1. Alright, then let's look at A. A is the other easy one. A is the amplitude. Amplitude meaning the size. Here we go from minus 1 up to 1, from minus 1 down to negative 3. That amplitude is 2. Alright, horizontal translation and period. Let's work out the period first. So period here, we look at how long it takes for this to repeat. To repeat, if we start there heading down, we go down, up, around once, and that's the same spot on the graph, there and there. The period is going to be 6. So if the period is 6, then if the period is 6, then what we have is saying the period is equal to 2 pi on 6. Oh, sorry, 2 pi on B. So that's the starting point for this line here. Period equals 2 pi on b. We can see from the graph that the period's 6. So we can say 6 equals 2 pi on b. Then we rearrange to get b by itself. Multiply both sides by b. 6b equals 2 pi. Divide both sides by 6. b equals 2 pi on 6, which is the same as 1 pi on 3. Alright, so we're starting to knock these away now. So b is pi on 3. One last one to get. And this one I think is the hardest. Sometimes you can see it. You can often see it when the axis is in terms of radians or degrees, and you can see how many degrees it's shifted. And especially when it's on the principal axis. But here, it's hard to tell how much it's shifted. And the way you can, I guess, see a shift is, you remember our principal axis that we've drawn in here. It should start there. Meaning it should start there going through 0, 0 on the principal axis. I know 0, 0 is actually there, and that's where the graph goes through, but originally the graph would have gone through 0, 0 on the principal axis. Only thing is it's been shifted back a bit, that way. And the struggle for us is to figure out how much it's shifted. So one thing we can do is look at the graph and write an equation out for all the bits we know so far. So all the bits we know so far is y equals 2 sine pi on 3 x takes c plus d. And then sub in a point that we know the graph goes through. It doesn't particularly matter which one we choose. We could choose -4, 0, 0, 0, or 0, 2. Sorry, 2, 0. I'm going to choose 0, 0. So 0 equals 2 sine pi on 3 multiplied by take c, because x is 0 as well, plus d. I should have written d there, because d is -1. Alright, and then we have to use some of our trig skills in order to solve this equation. So in order to solve this equation, we need to add 1 to both sides. 1 equals 2 sine, I'm going to write that as -c pi on 3. And then divide both sides by 2. 1 on 2 equals sine -c pi on 3. And note, this is what you'll do in your investigation, and showing this working is where you'll get your marks from in the investigation. Alright, so now we're thinking, well, sine of what equals a half? And we should know that sine of pi on 6 equals a half. Therefore, -c pi on 3 should equal pi on 6. So we know that when this is pi on 6, we get a half. And therefore we can write our equation like this. I'm going to multiply both sides by 6. If I multiply both sides by 6, what I get is -2c pi equals pi. Then I'm going to cancel the pi's out. -2c equals 1. And then c is going to equal 1 on -2. So c is -1/2. Alright, now that was quite a long, laborious process, and I apologise for the long video, but we have nutted out our graph here from what was quite a difficult pictorial graph to start with. Difficult because we shifted everything and we didn't have radians on the axes. Alright, there's one more to go. Next video, you'll learn how to do this with a calculator, which makes life a lot easier. Alright, thank you very much.